Good morning, ladies and gentlemen. We're going to continue graphing our trig functions with sine and cosine, and we're going to add a couple extra things that can change on us. So let's talk about what we know and what we are going to now use as new. So first thing, we have this really fancy, scary looking equation, but we've already talked about A and we've already talked about B. A, if you'll remember, is the amplitude that stretches it out vertically, and I'm going to leave that back at 1, so that's like our sort of parent sine curve would look something like this. But if you change the amplitude, you make it taller. B changes the period, so for example, if I make that 2, now instead of taking 2 pi to go one cycle, you can think of it as being twice as fast. It only takes 1 pi to do a cycle. We've done both of those things, but what we have not done is this x minus h and then this plus k thing. So let's first talk about the easier one, the plus k. Plus k on the outside, watch what happens. When you make this bigger, so if I do like plus 1, goes up 1. Plus 2, goes up 2. And when I say it's going up 2, what I want you to really think about is the midline is what's moving. The midline is now y equals 2 instead of y equals 0. The midline is now negative 1 instead of y equals 0. So you move the middle of the function up or down depending on what your k is. So this is our vertical shift. This is how we control vertical shifts. X minus h, this is a little bit backwards from what you might think. X minus h, this is going to move it left and right. So you can see how it moves it left and right. But it's tricky to maybe think about what's actually moving left and right. So I'm going to change this a little bit. Like, let's say x minus pi. If I type it in as x minus pi, what I want you to notice is this thing is now moved to the right pi units. So this is my start. And what's weird about that is when it says x minus pi, generally what you would think is a minus sign makes it go left, but it's actually backwards. When it says x minus pi, that makes it go to the right pi. So it's supposed to be a minus sign in the equation. If I do x minus pi over 2, you can see now it starts at pi over 2. So my sine function starts at pi over 2. The vertical shifts are pretty low stress. The horizontal shifts can be a bit tricky. So let's do a few of these together, and we'll see how it goes. Now, you might notice that this is written slightly differently. Instead of cosine of x plus 3, they put 3 plus the cosine of x. Just realize that, number one, this is a positive 3. The number is a positive number. It's positive, and it is being added. So that means you know it's not the amplitude. The reason that we write it sometimes this way, instead of how I had it just a second ago, is if you write it like this, sometimes it's tough to tell. Do you mean cosine of x plus 3 or cosine of x plus 3? So just to make it really clear, we put the vertical shift out front. Now, this plus 3 is going to move the entire function up 3. It's going to move the midline up 3. So what you can do is you could draw it like this, and then you could call this 3. But what we're going to do is we're going to just relabel the x-axis and say that is now 3. Instead of drawing an actual vertical shift, we'll just label the x-axis as being 3. Now in this problem, the coefficient is still in front of cosine is a 1 cosine x, so that means the amplitude is 1. But what's weird here is if you start at 3 and you go up 1, you're at 4, and now you're down at 2. So the range is not going to be opposites if you move the vertical shift. Everything else will be the same though. So you'll notice that there's no b value, so that means the period is still 2 pi. So we'll be counting by 1/4 of that, which is pi over 2. And since it's a cosine curve, you just got to remember cosine starts at the top, then goes to the middle, then back down, and it looks something like this. So our cosine curve will be like this. Ooh, pretty good. There we go. Pretty good. The amplitude is still 1. Didn't change. It was 1 cosine x. The domain is always all real numbers for sine and cosine. The range, though, is a little different. The smallest y value is 2. The largest y value is 4. So from 2 to 4. You'll notice how these are not opposites like they've been traditionally. Try another one. So remember, this is a plus 4. It's a plus in the front. The negative 2 is going to affect the amplitude. So the amplitude is 2, and the fact that it's negative means it's upside down. So an upside down sine curve is going to look something like that. Let's see. Our vertical shift here, there's a plus 4. That means we're adding 4. And if the amplitude is 2, then up 2 is 6, and down 2 is 2. So 1, 2, 3, 4. There is no b value, so again, the x-axis isn't changing. And now I just need to draw it. So it's a sine function, but it's upside down. It's upside down because it's a negative. And if I draw a negative sine curve, it looks like this. And you want it to be smooth. That's pretty smooth. Pretty smooth. Okay. Period, still 2 pi. Domain, all real numbers. Range, so the range here is from 2 to 6. 2 to 6. Okay. Vertical shifts, not a big deal. Horizontal shifts, let's try one of those. So first thing, you've got a 2 on the outside. That's the amplitude. Now there's no vertical shift, so it will be plus and minus 2. But this x minus pi is what's going to get you. So x minus pi means this whole function is going to move to the right pi. So instead of looking like this, we could redraw this and say, well, actually, it doesn't start until where it hits pi, which is normally in the middle. So it looks something like this. Now, we're going to do kind of the same thing we did before. Instead of drawing our horizontal shift, we're just going to relabel the y-axis pi. So now instead of starting at 0, our y-axis represents starting at pi. Now I'm still going to put 4 tick marks, but this is a little trickier. There is no b value, which means the period is still 2 pi. But if you are starting at pi and then the period is 2 pi, you start at pi, then you're going to end at 3 pi. And you can just think of it as 1 plus 2 is 3. But another way to think about this is if the period is 2 pi, let's take 1/4 of that and get pi over 2. And now realize that these intervals are all pi over 2, pi over 2, pi over 2, pi over 2. So we got to think of what we're going to add. This is 2 pi over 2's. So if you want to think about it as getting a common denominator. 1 pi is 2 pi over 2's. 2 pi over 2's plus 1 more pi over 2 is 3 pi over 2's. If you add another one, so this is 2, 3. Now this is 4 pi over 2. 4 over 2 is 2 whole. 2 pi over 2. 3 pi over 2, 4 pi over 2. This is 5 pi over 2, and then this would be 6 pi over 2. 6 over 2 is 3 whole. So you can still figure out what you're counting by, but if you're not starting at 0, sometimes it can be a little trickier. It's a sine function, so now that I've got everything labeled, that's the easy part. You just draw your sine curve, and then you make it. It's terrible. Terrible, terrible, terrible. It's okay. It's a little funky up here, but it's all right. Okay? Domain, still all real numbers. Range, negative 2 to 2. And we're in brackets. Those are brackets. All right, let's try another horizontal shift. So x minus pi over 6. That means this whole thing is going to go to the right pi over 6. Remember, it's kind of backwards. When you see a minus sign, normally I think going left, but in functions, it's going to go to the right. The amplitude is 3. And this is your b value. It's outside of the x minus h, whatever it is. So the period is supposed to be 2 pi. In this problem, it's 2 pi over 3. So that means this one's going to be pretty tricky. The amplitude is 3. So there we go. 1, 2, 3, 4. All right, so let's figure out now where we're going to count, or what we're going to count by. 2 pi over 3, there are 4 tick marks. So I'll multiply by 1/4. 2 pi times 1 is 2 pi. 3 times 4 is 12. And this reduces to pi over 6. That means that I'm counting by pi over 6's. Okay, but where am I starting? Well, 2 pi over 3, well, I'm sorry, we're starting at 1 pi over 6. So the horizontal shift is pi over 6, and now I need to add another pi over 6. Okay, this is 1 pi over 6. If I add pi over 6, now I'm at 2 pi over 6. 2 over 6 is 1/3, so pi over 3. 1 pi over 6, 2 pi over 6. 3 pi over 6, 3 over 6 is 1/2. 4 pi over 6, 2 pi over 3, and then 5 pi over 6. So the period is 2 pi over 3, but since we started at pi over 6, we don't end until 5 pi over 6. I've got it labeled. It's a cosine function, so it starts at the top and goes down in the middle and back up. So it's going to look something like this. Yay. Okay. Domain, all real numbers. Range, negative 3 to 3. Okay. So when you do this, figure out what you're counting by. But here's another thing that you can use to kind of help you. If you know the period is 2 pi over 3, and you know you're starting at pi over 6, adding these together should get you wherever you're going to end. Now, to do that, you would need to get a common denominator. So this is 1 pi over 6 plus 4 pi over 6's, which is 5 pi over 6. So it's like a good check. If you add the period to the shift, you should get where you end. And since I got 5 pi over 6, that means I did it right. All right, last one. This is probably the trickiest thing that can happen when it's an x plus. That means it actually goes left pi over 2. So now this no longer is y equals 0. This is negative pi over 2. So we're actually to the left of the y-axis. Somewhere in here is the y-axis. But when you start negative, it can be a little tricky. The amplitude is still 4. So this will be negative 4 and this will be positive 4. But it is going to be an upside down function. The other thing is, since the period is 2 pi, we have a b of 2. The period in this problem is 1 pi. So let's talk about what we're going to count by. If the period is pi, 1/4 of that is pi over 4. So I'm counting by pi over 4s. But I got to figure out where I'm starting. This is negative pi over 2. So if you want to do negative pi over 2 and you want to add pi over 4, well, maybe you can do this in your head and say, oh, this is negative 2 pi over 4s, and I'm going to add 1. This is negative 2 pi over 4s, and I'm going to add 1, which is going to get me negative 1 pi over 4. So this is negative 2 pi over 4s. Add 1, you get negative 1 pi over 4. Add another, you get 0 pi over 4s. Add another, you get 1 pi over 4. And add another one, you get 2 pi over 4s, which is pi over 2. If you think about this as like change, this might help you. This is negative 50 cents. This is negative 25 cents. This is 0. This is positive 25 cents and positive 50 cents. If you have negative 50 cents and you add $1, you are now at positive 50 cents. If you think about quarters, sometimes that helps. Domain, all real numbers. It's not my best infinity sign. Range, negative 4 to 4. I just need to now sketch it. It is a sine function and it is negative, so it is upside down. So it goes down, then it goes back up, like so. It's okay. It's not my best, but it's all right. Okay. So there's your vertical and horizontal shifts. If you can throw that all together, then that's going to set us up for our modeling project. So before you do that, make sure you hit that like and subscribe button.